want to show you how to make or how to solve exponential equations. An exponential equation is an equation where the variable is in the exponent somewhere. And spoiler, I guess, the tool to fix that is a logarithm. Maybe you remember those before. So this, I hope, is a little bit of a review for you. So here is a question. It says, consider this equation and solve it for z. It's asking us for two different answers. It wants the answer in exact form, and it also will want an answer approximated using a calculator. So the process to solve something like this is, notice how the variable is in an exponent on top of base 10. So my first goal is going to be to try to get this 10 chunk alone. And if I can do that, then what I'll do is take the logarithm of both sides. So first thing, that 5, I don't like it there. I'm going to divide both sides by it. That gives me 10 to the something equals 6.4. And at this point, now that I've got that 10 chunk alone, I want to take the logarithm of both sides. And I'm going to purposefully choose log base 10. Logs come in a couple different forms. There is, well, you can have log to any base, but on your calculator, logs come in two different forms, either log base 10, which is the LOG button, or log base E, sometimes called the natural log, that's the LN button. And so, anyway, this one being a 10 to the problem, I am going to take log base 10 of both sides. It looks like this. Just write log of this side and log of this side. And in a follow-up move, the reason I did this log of 10 raised to the is log base 10 and 10 raised to the are inverse operations, and so they cancel out. And so over here, the log and the 10 raised to the undo each other and leave behind simply z plus 4. Excuse me, z over 4. And on this side, log of 6.4 is a number, which I'll eventually calculate on my calculator, but right now I'm leaving it in exact form because that's what they had wanted over here. So one more move it looks like to get z completely alone. Since it's been divided, we'll multiply by 4. And this expression, 4 log of 6.4, that's the exact form that they're looking for in this answer. And to actually evaluate that, simply type it into your calculator, and 4 log of 6.4, and gives us 3.224 and a whole bunch of other numbers, and they wanted us to round, in this case, to the nearest thousandth, so I chose the third decimal place to round to. So there's the basic idea. Here is a slight variation, negative 5 times e to the 10t. Again, variable in an exponent suggests eventually I need to use a logarithm. The fact that it's on top of base e suggests I use ln eventually. But before I do that, I'm going to try to get this e factor alone, and so I will divide both sides by negative 5. That gives us e to the stuff equals 6. And then when I take the natural logarithm of both sides, the natural log and the e cancel out, and I'm left with just the stuff, which in this case was, the exponent was 10t. And on this side, the natural log of 6. Again, it's a number I'll calculate eventually. Dividing both sides by 10 gives us our exact form of the answer, logarithm of 6 over 10. And if you type that into your calculator, you get an approximately 1.79. And then I would probably type this in Khan Academy and get it wrong because I rounded to the nearest hundredth instead of the nearest thousandth. That would be frustrating, wouldn't it? All right, here's a different type of question, an application of it. So a cup of hot coffee is left to cool down, and when it cools down, its temperature, do it from your perspective here, its temperature falls in this curve like and eventually flattens out. And so that's modeled by this sort of equation. We'll take a look at its graph in a little bit. But the first question is simply, what will the temperature be after 10 minutes? And so that means our m, our variable, is 10. And so we plug a 10 in for m. And it's a pretty quick, simple evaluating question. I would type it all into my calculator right away and get an approximately 58 minutes. And so I'm sorry, 58 degrees Celsius. So if I wait 10 minutes, my temperature will have gone down from 74 to 58. And that's still, I think, too hot probably to drink. But anyhow, that's that question. It's kind of a boring question. You just put a number in and get an answer. So here is a follow-up question. It's a little bit more interesting, I suppose. When will the temperature reach 30 degrees? And so at this point, it's going to taste cold because 30 degrees, if I remember right, is just under body temperature. And so you probably aren't going to like it anymore. But anyway, how much time will that take? To do that, now I don't know what M is, and so I can't put a number in there, but I know that this temperature, T of M, needs to be 30. And so I'll write a 30 in there and do whatever I need to do to solve this. And so again, I want to get this chunk with the exponent by itself. And so I'm going to do a few moves to make that happen. We'll subtract the 21 and then divide by 74. Gives us the fraction 9/74 is equal to 10 raised to this negative 0.03m. And then I will take the logarithm of both sides. To do that, I'll use log base 10. And on the left-hand side, I'm just going to leave that be. But on the right-hand side, that undoes the 10 raised to the exponent of 0.03m. And so that leaves behind negative 0.03m. We'll divide both sides by that. And here, this means nothing to me. I need an actual number to know how many minutes I've got to drink my coffee. And so when I type that into my calculator, that'd be about 30 minutes. So this must be a coffee cup that like isn't one of those nice insulated ones, but just a regular coffee cup. And I think that's about right. You leave it out for half an hour and it's going to be about lukewarm. Now, I had said we would take a look at the graph of this and suggest another strategy for solving this equation, which is to solve it by graphing. And so to do that, let me type this into Desmos a moment. We'll see if I can remember it. 21 plus 74 times 10 to the, that's an older file. Here we go. 21 plus 74 times 10 raised to the negative was it 03? I think it was 0.03. And then you can do either t or, actually I think I'm going to use x. Uh-oh, I'm not seeing anything. Yeah, that's because I didn't really think about what the window settings ought to be. So y-axis represents temperatures and x-axis represents time. And so let's adjust some settings here. Time in minutes. And we know from the two problems we answered that we're looking on the scale of like 30 to an hour. And so maybe I'll go from 0 to 60 minutes. And then y-axis is temperature, and that was in Celsius. And temperatures we're thinking about here are 100's boiling, so you can't go above 100. So why don't we start from 0 to 100 and see what we can see. Ah, yes. Here's a good one. Scroll out just a little bit. So this is the starting temperature of the coffee and cools down significantly. Notice it's got an asymptote, and that would be whatever room temperature is in your location. Looks like that's close to 20. Well, it's exactly 21 from our formula here. But the real question is, how do I use this to help me answer the questions? The first question was, what's the temperature after 10 minutes? That's easy enough. You can just drag around until you see 10. And there's the 58.08. The other question is, when did my coffee reach 30? And you can do that either by dragging until you see a y-coordinate of 30, or maybe a little more convenient is make a y equals 30 line and see where the intersection is. And so that was 30.5 minutes. Anyhow, I hope that helps give you some tools that you can use to solve equations. Hopefully you can do it on paper, but the graphing idea is a good idea too. It's just not always available on quizzes and tests, right? So let me know if you have any questions, and catch me in the next video. See ya.